Hello, my name is Matthew Luke, and today I'm going to be presenting on my co-op experience during the summer of 2021. The company that I worked for was called ATI Industrial Automation. They're based out of Apex, North Carolina, and they design and manufacture tool changers, force torque sensors, and a few other products that you might see at the end of a 6-axis industrial robot arm. I worked in their electromechanical engineering department for this rotation, mostly working with their tool changer module products, which I'll get more into later. And I was working as a design engineer with a team of 4 other engineers under the supervision of William Barrickle. This was my 3rd rotation out of 3 at ATI. In this presentation, I'm going to be highlighting the 3 main projects that I worked on during my rotation. I served as the project leader and also as the design engineer on the project. The first one is a servo motor pass-through module. The second one is a tool changer valve adapter. And the third one is a module that transmits electrical signal. I'll also go through my overall takeaways after that. Pictured on the right is what's known as a servo motor pass-through module. So there's a robot side, which is on the top, and then a tool side, which is on the bottom. These modules are used to pass servo motor power and signal from a robot to a tool. So these modules are used so that you can have multiple different tools that are all used on the same robot. Servo motors are commonly found in like vehicle welding applications. So somewhere where you have welder arms coming together, you have a servo motor getting feedback from a controller and also providing some feedback back as well. So this project, I kind of got in at the start and got to see it through until it was being produced. So I got to work pretty much through the full project workflow and understand how you take a customer request and you turn it into a product that's going to end up on their robotic tooling line. So this project had a little bit of back and forth with the customer, with applications and manufacturing, mainly surrounding some of the wiring and assembly drawings that I needed to create with all the little electrical pass-through pins. There can be some pretty complicated wiring based on what signals the customer is trying to pass. So I got some good experience kind of working with different groups of people and making sure that everyone was happy with the end result. The second big project I worked on during my rotation was a tool changer valve adapter. So this allows someone with an older style kind of like module that would be used to control the tooling side be interfaced with like a newer tool changer. So these provide air in and out to the tool changer to actually like lock and unlock the robotic tooling. So these have a combination of both an electronic valve and a mechanical housing and filtering pneumatic system. So this project, I really had to focus on like machine part design. There are 2 configurations of the module shown on the right and the left here, just based on what kind of product the customer already had. And I had to use the same housing for both. So it was a really good exercise in just figuring out what features were important and how I was going to be able to make it all work. This product also went through a series of design and manufacturing reviews. So it was really good experience getting to call a meeting, show actual professional engineers what I had come up with, what I had changed, ideas that I had, and gather their feedback on it. So I thought that was really useful and helped me gain some skills in design. Part of this project involved doing kind of a cost reduction on the machining of the part. This machined like valve body was the most expensive part on the bill of materials and needed to be reviewed through the design reviews, meeting with some machinists. I was able to save some money on actual machining of this part by doing things like making larger internal radii and decreasing large pocket depths. There are also some functional differences between like the concept design and then the prototype design. You can see that kind of in the middle. There's those two holes. These are used to hold like wires in behind the valve. It sits in there, and applications that had problems with customers pinching wires. So that's a good example of where gathering feedback from other engineers in the company can help you design a more successful product. The third project that I worked on was a module that was designed to transmit ATI's force and torque data from their sensor through a tool and then through a robot arm back to a controller. So this was more in the like design verification and testing phase of the project. So I was involved with kind of the creation of pass and fail criteria for like signal quality and stuff like that. So having to hold meetings with different engineers and get their feedback on, like what they qualify as good signal, stuff like that, which was interesting to see. Kind of like that aspect. Being a mechanical engineer, it was interesting to see how a product that I was designing could change the output of electrical signal, and how basically you could create a great design of like the actual product itself, but if you don't have a good way of testing or verifying that it works, you could end up selling something faulty. My overall takeaways from this rotation, I felt, were kind of in three different categories. So the first one, kind of my impact on the organization. I believe that I had a positive impact during this rotation because I was contributing to designs that were directly requested and created for like large customer tooling lines, specifically in like the automotive industry. I also got to work on some cost saving opportunities in these projects. So I got to save ATI a little bit of money on machining some of their components for these new products. I think that I also got good insight into the industry as a whole. This was my first rotation working with like a full team of design engineers, getting feedback on my designs and getting to kind of pick their brains and learn from them. And I think that I have a much greater understanding of kind of like machining and manufacturing, as well as like getting prototypes and kind of how you go from a concept to a production release design. I think there's like a lot of steps in there, and it was great to get to be a part of a product that's going through its kind of design phases. I also think I grew kind of in my project management, having to balance 3 different projects, meet with people, but also do like the technical tasks and the documentation for the projects. It was my first exposure to using Scrum as a project management technique. So the group would have a series of meetings each week to make sure that everybody was on track and we knew kind of what was up next for everybody. So I thought that was interesting to get to experience a different style of project management rather than kind of the standard like waterfall method. Like I said, I got to work a lot of my technical skills. This rotation was very heavy in SolidWorks use and GD&T. I actually got to get a TechEase GD&T certification by just taking kind of a class and getting to learn a little bit about GD&T and its application. And I think that this confirmed that I'm hoping to get a job as a design engineer once I graduate. Thanks for listening.